First off, this is section 5.8, talking about the SAT strategy session today. Talks about landscaping company that estimates the price of a job in dollars using the expression 60 plus 12 NH, where N is the number of landscapers and H is the total number of hours, which of the following is the best interpretation of the number 12 in the expression. So what the SAT question wants us to do this time is go back to analyze what these numbers mean. Keep in mind what we just learned, that the number without the variable tends to be your initial value, or your y-intercept, which is your starting point, and this is typically your rate of change. And so the 12 is some sort of rate of change here that we know is going on. The 12 is going to be keeping on repeating. But again, using common sense and what SAT questions usually want you to use, this is a charge in dollars. So this is a price in dollars that we're talking about. So it could be A because it's talking about how much the company's charging. I don't think it's B because if this is an equation for dollars, this is talking about the number of landscapers. I don't think that's the case there. This talks price again, and this is talking each landscaper working 12 hours a day. I don't think it's that either. So what we did just by using common sense here is understand this represents a price, and that there's two answers here that don't talk at all about price, and so it has to be A or C so far. That at least gives us a 50-50 shot. But here's what you have to remember. This is talking about the price of each job increasing by 12 every hour, but the thing is, it's not just every hour, it also increases per N, which is every landscaper. And so the only thing that talks about hours and landscapers is A, where it talks about charging 12 per hour for each landscaper. There's 12 per hour and there's 12 per landscaper, and that will give you the answer of A on that. Alright, so again, when you start getting into these questions, when you go to your final at the end of the semester, use your common sense, answer questions based off of what you know. Don't just panic and think I don't know how to do this and leave it at that. Other than that, today we're going to learn how to graph an absolute value function. The parent function of an absolute value function is y is equal to the absolute value of x. Remember that the absolute value bars eliminate the negative portion of any number inside of it. Looking at a 5-point chart and a graph, here is the graph of the parent function. Typically, remember what I told you is that in order to graph, you want to make a 5-point chart using the numbers -2, -1, 0, 1, and 2. If we did the absolute value of -2, remember that the absolute value of -2 comes out as +2. Absolute value of -1 comes out as a +1. Absolute value of 0, of course, is 0. Absolute value of 1 does not make it negative. Excuse me, it just kind of brings the same number, and then 2 also brings out a 2. And so when you go to plot these, -2, 2 means go back 2 and up 2. Go back 1 and up 1. 0 and 0 is here. 1, 1 is here. And 2, 2 means go over 2 and up 2. Now as a result, what you get is a graph that is shaped something like this. And again, my graph is not perfect, but it gives you the general idea of what the absolute value looks like, because for every part that you go over, you're going to go up the same amount, even as you go negative. That is your absolute value graph. That is what we call the parent graph. And what we're going to do is use the parent graph to determine other shapes of the absolute value graph. So what I do is I try to remember that the absolute graph, or that the graph is shaped like a V, because the word value in the phrase absolute value. The most important part is remember that the vertex of the V is at the origin. So the vertex of this is here, and that's really the point that you're going to have to use on all your graphs. So other than that, you just go 1, 1 and -1, 1, and that's going to give you the shape that you're looking for. Alright, but again, absolute value starts with a V, and so that helps me remember that the graph is shaped like a V. There are 3 changes that we have to memorize if we're going to be successful today. And the first is created by a negative sign outside of the bars. Look at what happens when we evaluate a 5-point chart for the following function. If we were to do this, again, y or x, y with -2, -1, 0, 1, and 2. If you plug in -2 into this, you get the answer of 2, but that makes it -2. If we plug in a -1, this makes the answer of 1, but that makes it -1. 0, of course, cannot be negative, it's just 0. If we plug in 1, that makes it a 1, but that makes it a -1. If we plug in a 2, the answer is 2, but that makes it -2 because of the negative on the outside. And when we go to plot this, -2, -2 is here, -1, -1 is here, 0, 0 here, 1, -1, 2, -2, and I'm not going to use a straight edge, but you can kind of see, for the sake of your notes, that all we did was take the graph and flip it upside down. This will always happen whenever you have a negative sign outside the absolute value bars. So anytime you have a negative outside the bars like this, the graph is going to open down. And that's the first thing you have to memorize in terms of this lesson. The second shift occurs when a number is added or subtracted outside of the bars. This is similar to our y-intercept, because remember the y-intercept moves up or down the y-axis. Notice that the value of b simply moves the graph up or down. So here you have mx and then plus b. This would be kind of like your mx plus b here. So what we would know from here is that this should cross at -4. Let's see what happens when we do our xy chart. -2, -1, 0, 1, 2. Again, putting -2 in here makes the answer of 2. 2 minus 4 is -2. Putting the answer of here makes the answer of 1. 1 minus 4 makes -3. 0 minus 4, of course, is -4. 1 put in here makes the answer of 1. 1 minus 4 is -3. And 2 in here makes the answer of 2. 2 minus 4 is -2. Plotting these, -2 goes to -2. -1 goes to -3. 0 goes to -4. 1 goes to -3. 2 goes to -2. And again, not using the straight edge, but just make sure you do it on the test. But you can see that this graph just simply moved down 4 places. So all this really did was it took and it moved the vertex which was the v part of that, or the most important part of that, down 1, 2, 3, 4, which is all that happens whenever you have a number there. So again, it says, notice that compared to the parent function, the graph simply shifted 4 units down. That's because of the -4. If there was a +2, then it would have shifted 2 units up, and so on. Alright, so negative number makes it shift down, positive number makes it shift up if it's on the outside. And the third shift before we get to our practice is when a value is added or subtracted inside the absolute value bars. This is grouped with the x variable, and so for me it directly affects the x direction. So since this is with x, it affects x, which is going left and right. It is a tricky value because it typically shifts the opposite direction. Again, I hope you're writing down notes. Look at the following example. Let's again look at a xy chart officially. -2, -1, 0, 1, and 2. Which probably will not help us, but let's see what happens. When we do -2, we get -2 plus 2, which is 0. -1, -1 plus 2, which is 1. 0 plus 2, which is 2, 1 plus 2, which is 3, 2 plus 2, which is 4. Really, that doesn't help me because it simply gives me these points. And you notice that I don't see the v, and that's because I did not go far enough over. So it means that I also have to check some numbers smaller than -2, so I'll try -3 and see what happens. When I plug in -3, -3 plus 2 makes a -1, and the absolute value of that is 1, which puts me here, and you notice that your v is there now. -4 plus 2 is -2, which gives me the answer of 2, and I think we have enough now to see, again without the straight edge, just for the sake of notes, that's what happened, that the graph that was right here simply moved over 2 spots to the left. So again, notice even though we have a +2, it shifted left instead of right, and it means that we treat the -2 like, or +2 like a -2. Same thing on the other side. Alright, so if it's negative, you treat it like a positive if it's on the inside, and if it's positive, you treat it like a negative on the inside. So again, what you can think is positives on the inside go left, and negatives on the inside go right. Alright, so other than that, let's look at some examples and see how we apply all this weird stuff that we just learned about. And again, you might want to take notes on this, and you might want to follow exactly what I do because it will help you out. First off, it says graph y is equal to the absolute value of x plus 3. The first thing I would do is just kind of use a dotted line to draw a cheap sketch of what the graph looks like. And then plus 3, and you look here and you say to yourself, this is outside. This represents your y-intercept, if you remember. And plus 3 means add 3, or up 3. And so we simply take this thing here and go 1, 2, 3, and we would go over 1, up 1, back 1, up 1, because remember that's your key part there, and you draw your graph based off of that. So again, on your test, on your quiz, actually on your test at the end of the week, make sure you use a straight edge. I am doing this for the sake of time, making sure we get through it. But all you do is you take that graph, the +3 means move up 3, and there is your graph. Alright? So this is where you have to start studying. This is where you want to make sure you have your notes. Outside moves up and down, inside moves left and right. Here, you have your graph of absolute value, which again started out looking like this. But this is x plus 4 on the inside. And remember that inside is left and right shift, and that we also use the opposite of that number. So since we have a positive 4, we will use it as a negative 4. Remember that a negative 4 usually means to go left on the x-axis. And so what we will do is we will go 1, 2, 3, 4. From there, that vertex, we go over 1, up 1, we go back 1, up 1. And again, that would give us, I'm not using the ruler, but again, that would give us the graph that we are looking for. Again, that 4 is positive. Because it's on the inside, we use the opposite. And because that's negative, that means go to -4. And that would finish it off. You have to make sure you write these notes down. You have to make sure you have an understanding of this. This will help you throughout the rest of your graphing of quadratics and anything else that you've seen before, because the rules stay the same. Here, it wants us to graph again. I'm not going to do the, actually I will do the dotted line graph just to make sure we see the parent. This 2 is outside, which is your y-intercept, and it moves down 2. So the first thing that happens is it moves down 2. That's the first part. The second thing that happens is this is an inside number, and remember the inside is left and right, and that the inside left and right number, that we use the opposite value. So -1 should be used as a +1, and +1 means that we go 1 to the right. And so after we move down 2, we'll go 1 to the right, and that is our actual vertex there because there's no other shift. Once we get that, we do our typical work: over 1, up 1, back 1, up 1. And again, I am not using a straight edge, but you might want to do it if you want credit. That is the graph that you would have. It is still a absolute value graph, but it is a absolute value graph that has shifted 2 down because of that, and 1 over because of that, and that would be what you do. Alright, so again, this moves it down, this moves it right. That's what you have to know. Example D. Negative absolute value of x minus 2. Again, this is our parent function here. First thing that happens is this negative actually makes it turn upside down. So we really don't even look at that anymore. We're looking at the parent function that is upside down. This then is a inside number, and as the inside number, it goes left and right. As an inside number, we also use the opposite value, and because it's a -2, that means we view as a +2, and +2 means 2 to the right. And so all we have to do, because that's the only shift that happens outside of the flip, is we take this graph and we move it 2 to the right. Instead of going over 1, up 1, the parent function says we actually go down 1 from there, and that would be the graph that you use. Alright, so again, this is a easy section, but it's also a tough section if you're not aware of what you're supposed to be doing. And the last one, first off, the negative means that it flips upside down, so we know we should be seeing an upside down V. This -1 means 1 down, because remember that's your y-intercept, and as you get faster you'll say this is a +3, which we treat as a -3, which means we go 3 to the left, and it's left because that's with the x, and so we know it's an upside down V that has moved 1 down, 3 left. So instead of going over 1, up 1, we go over 1, down 1, and we get those two graphs, or those two sections of it. Alright, so this does conclude the information for Chapter 5. There is no bell ringer today. Be sure to begin studying for the test this Friday. Tomorrow is set as a review day, and then we will look at pre-test activity together on Thursday. For now, log into MathXL and begin working on today's assignments. This is chapter 3 or chapter 5.8, and so that's what you would do is 5.8a and 5.8b. Other than that, again, make sure you ask questions on everything that you still have questions on, so you can get them taken care of before that test comes up and this haunts you somewhere or another on Friday. Good luck.